All of you have revised aldehydes and ketones.
Yeah, okay, so I had a doubt in the ammonia wala part. The the semi
Semi-carbazide.
carbazide. Ha.
That reaction you want me to explain, semi-carbazide one.
Yeah, and then you gave a condition also.
Hmm. That
That.
there are two NH2 groups.
Ha.
Okay, and explain that. Except that, what is the
No,
last thing we have done? Reduction reaction.
Clemenson,
No? Reduction.
Clemenson reduction, yeah.
Okay. Any other doubts? Arjun, you have revised? In last class, we did that chemical properties. In chemical properties, we did nucleophilic addition reactions in which there were few reasoning questions. Aldehydes are more reactive than ketones. Aliphatic aldehydes are more reactive than aromatic. Then we did the reaction with HCN cyanohydrin, reaction with sodium hydrogen sulfide addition product, reaction with alcohols, acetals, ketones, alcohols, acetones, and ketyls. Then Grignard reagent alcohols are formed. Then ammonia derivatives, in which there were many compounds. We have studied hydrazine, 2,4-DNP, hydroxylamine, that whole. So there is one reaction under this reaction with semi-carbazide. What is semi-carbazide? First, you have to write hydrazine. Hydrazine is NH2, NH2. So when you remove one hydrogen of hydrazine and replace it with amide group CONH2, it becomes semi-carbazide. So it is NH2, NH, CO, NH2. When it reacts with this compound, then water is removed, H2O, and you have to combine the remaining part. Removal of, or you can say replacement of one hydrogen of hydrazine with the amide group, CONH2. Now, in this, we have studied two conditions. Okay, there were two NH2 group in this compound. One is here, one is here. But only one is taking part in the reaction, not the other one. What was the reason? The other group CONH2, this the lone pair is in resonance with the benzene CO group. If lone pair is in resonance, then this NH2 will not act as a nucleophile. So that is why only the other side will take part in the reaction. So if they give you CONH2, this group CONH2 remains as it is. You have to remove H2 from the other side. Sometimes they will write the compound like this, NH2CO, NH, NH2. They will write it like this. Then don't remove H2 from here. It should go from this side. H2 and O will go, and you have to start writing from this side, NHCO, NH2, like this. There is one more condition we did for all the ammonia derivatives. This reaction takes place in weakly acidic medium. It should not be strongly acidic. Weakly acidic, H+. Why it takes place in weakly acidic? Because if you use strong acid, then all ammonia and ammonia derivatives are basic in nature. So they can form salt with the acids, and then they will not act as a nucleophile for the reaction. These reactions takes place in weakly acidic so that they cannot form salts with the ammonia derivatives and prevent the reaction. Bhumika, only this part? Is it clear or still some doubt is there?
No, it's clear. I had a doubt in why we couldn't remove the NH2 from the H2 from the first wala.
First. Okay. So because of the resonance, this group will not participate in the reaction. Now, next thing we have done the reduction reactions. In reduction, we did two reduction reactions. One is Wolff-Kishner, another is Clemenson. Wolff-Kishner is the reaction with hydrazine followed by the reaction with glycol and KOH. Clemenson is the reaction with zinc amalgamate HCl. Now, third reaction I am starting, then we will practice the questions. Oxidation. This is the third chemical property. Oxidation. Under oxidation, there are four reactions. First reaction is KMnO4. reaction with KMnO4 or K2Cr2O7. Shivani, tell me, if you use these oxidizing agent, then aldehydes gets oxidized to which functional group?
One second, ma'am. Um,
There was one oxidation series we have done, na? Alcohols
yes, no,
are
I remember doing this. One second.
alcohols are oxidized to aldehydes, and aldehydes are oxidized to
Ketones,
carboxylic acids.
oxalic acid. Okay.
Alcohols, aldehydes, acids. So when you use either mild or strong, aldehydes are always oxidized to carboxylic acids. So RCHO converts into COH. If we are converting alcohols to aldehydes, we use mild oxidizing agent. Alcohols to carboxylic acid, strong oxidizing agent. And aldehydes to acid also, we can use strong. There are more also, but strong will work here also. Suppose you have propanol. Upon oxidation with KMnO4, Arjun, it converts into
Ethanoic acid.
why carbon is reduced.
Oh wait, 3 carbons I didn't see.
So it's
Propanoic acid.
propanoic acid. CHO converts into COH. With KMnO4, K2Cr2O7, always CHO converts into COH. Now let us suppose you have ketone. This point, listen carefully. This is right. So ketones, when you react ketones with KMnO4 or K2Cr2O7, then this will undergo oxidation. So in this case, what happens, because aldehydes were the terminal groups, so it will easily oxidize to carboxylic acid. But ketones are non-terminal groups. So in that case, how oxidation takes place? In this case, the bond breaks between C and C, either from left side or right side. I will tell you from which side the bond will break. Bond breaks from CO, either left or right. So that is why, because it needs the cleavage of CC bond, this oxidation takes place under drastic conditions. Because drastic condition means high temperature and pressure is required. The reason is ketones oxidation involves the cleavage of CC bond. Now what happens? This side you have CH3CO. This side you have CH3CH2. So both the carbons, CO carbon, this carbon and this CH2 carbon, it gets oxidized to carboxylic acid. You will get CH3COH. This side also you will get CH3. This CH2 converts into COH. The group from where you break the bond, that side both the carbon atoms gets oxidized to COH. This CO converts into COH. This CH2 converts into COH. So you will get 2 molecules of ethanoic acid. Now why drastic condition is needed? Because in ketones, it involves the cleavage of CC bond, because ketones are non-terminal. Let us suppose they will give you this compound and you have to find the product. KMnO4. Drastic conditions. Aditi, can you tell me what should be the product?
Ma'am, CH3, C, COOH.
CH3COH. From where will you break the bond? Either from left side or right side of CO.
CH3, CH2, COOH.
And this side also CH3CH2 COOH, propanoic acid as a product. Now all of you listen carefully, which side, left side or right side? Which side you have to break the bond? there is one rule which is known as Popov's rule. What does Popov's rule says? The CO group will go on that side which has lesser number of carbon atoms. Which has lesser number of carbon atoms. Now you can see on left side of CO you have 2 carbons. If this is a compound, left side you have 2 carbons, right side you have 3 carbons. So bond breaks from that side so that CO group goes with that side which has lesser number of carbon atoms. So we'll break the bond from here. So here what you will get? This CO gets oxidized to COH, CH3, CH2, COH. And this side also, this CH2 gets oxidized to COOH. We'll start from right side, CH3, CH2, COOH. 2 molecules of propanoic acid will be formed. So this is the first reaction under oxidation, reaction with KMnO4 or potassium dichromate. With this, aldehydes and ketones both are oxidized to carboxylic acids. Aldehydes oxidation takes place under normal conditions, but for ketones, drastic conditions are required because it involves the cleavage of CC bond and it follows Popov's rule. CO bond cleavage takes place in such a way that the CO group goes with that side which has lesser number of carbon atoms.
Ma'am, you said that the will break the bond and the side with lesser number of carbon atoms, but here there are 3 and on the other side there are 3 as well.
You have to first see CO group. On left side of CO, how many carbons are there?
2,
Right side?
3.
3. So you have to break in such a way that CO goes with the lesser carbon atoms. So that's why I broke it from the
Okay.
right side so that CO goes with 2 carbon atoms. That is the first reaction under oxidation. Write on this, then I will come to the second one. Then now second reaction is Tollens reagent. This you have done in lab also for aldehyde silver mirror thing. So what is Tollens reagent? It is ammonical solution of silver nitrate. Ammonical solution of silver nitrate. Its formula you have to learn. Ag, it is a coordination compound, AgNH3 twice positive charge. This is a formula for the Tollens reagent. AgNH3 twice positive charge. So when you react aldehydes with Tollens reagent, in the presence of base, all this reaction takes place in the presence of base. Then what happens? Because Tollens reagent is an oxidizing agent, so these aldehydes are oxidized to carboxylic acids. But because we are using base here, you will get the salt of an acid. Instead of writing RCOOH, we are writing RCO minus. Why so? Because if I am using NaOH here, you will get RCONa. If I am using KOH here, then you will get RCOK. Because when we are using any base, then the acid is formed in the form of salt. So instead of writing RCOH, we are writing RCO minus because base is used in the reaction. And side product is you will get Ag, which is a silver mirror. Ammonia gas is released and water is formed as a side product. So tolerance reagent is an oxidizing agent. It converts aldehydes to carboxylic acids. It oxidizes aldehydes, but itself gets reduced to silver mirror. So tolerance reagent formula, you have to learn it. It's very, very important reaction. AgNH3 twice H plus. What is important in this reaction? The important part in this reaction is, this is the test for aldehydes. Test for aldehydes. Only aldehydes show this reaction. Ketones does not show the tolerance reagent. Like aldehydes on reaction with tolerance reagent gives you silver mirror, but ketones does not react with tolerance reagent. If the question comes, how will you distinguish between aldehydes and ketones? We will do this reaction. You have to write this test. Ketones does not react. React with tolerance reagent. Aldehyde gives silver mirror, but ketones does not react with tolerance reagent. Is a distinguished test for aldehydes. They ask you, how will you distinguish between propanol and propanone? How will you distinguish between acetophenone, acetaldehyde, benzophenone? So always whenever one molecule is aldehyde, another is ketone, acid, any molecule, you will write tolerance test. And observation is, aldehyde gives you silver mirror, but other compound does not react. Now third oxidizing agent is failing solution. Failing solution. There are total 4: KMnO4, toluene, phthalate, and iodoform. Now, what is phthalate solution? Phthalate solution is a mixture of two compounds, phthalate A and phthalate B. What is phthalate A? It is aqueous copper sulfate solution. Aqueous copper sulfate solution. And what is phthalate B? It is Rochelle salt. Sodium, potassium, tartarate, which is called Rochelle salt. When you mix phthalate A and phthalate B in equal quantities, then it is called phthalate solution. Mixing of these two in equal quantities will give you phthalate solution. So phthalate A is aqueous copper sulfate, phthalate B is sodium potassium tartrate. So when you react aldehydes with phthalate solution will just write ionic equation copper 2 plus ions. Because copper sulfate undergoes dissociation to a very lesser extent. So when you add sodium potassium tartrate, it gives you copper ions in the solution. It reacts with phthalate solution again in the presence of base. Reaction also takes place in the presence of base. So again, it is an oxidizing agent. Aldehydes are oxidized to carboxylic acid, RCO minus. And copper ions or phthalate solution gets reduced to Cu2O. It is cuprous oxide. It's not cupric oxide. It's cuprous oxide, which gives you reddish brown PPT. Reddish brown. This is very important question for MCQ. Which compound is formed with the reaction of phthalate solution and aldehydes? It is cuprous oxide, Cu2O, which has a reddish brown PPT. Because it is an oxidizing agent, aldehydes are oxidized to carboxylic acids. Phthalate solution, copper 2 plus, are reduced to cuprous oxide. And this is also given by only aldehydes, aliphatic aldehydes. Aromatic aldehydes and ketones does not give this reaction. This is also used as a distinguished test. But the thing is, here aromatic aldehydes also does not react. So tolerance is the safer test if you have to write between aldehydes and ketones. Aromatic aldehydes and ketones will not give this test. Only aliphatic aldehydes react. So this is the third oxidation reaction, Fehling solution.
Mom, in this, so we need to add Fehling A plus Fehling B, right?
First, you have to make Fehling solution. You take Fehling A and add Fehling B in that in equal quantities. Then your Fehling solution is ready. Then you add aldehydes and base, you will get the product to that solution. The function of Fehling A and Fehling B is just to give you copper ions in the solution. Now come to the last oxidation reaction, iodoform test, iodoform reaction. Iodoform reaction is given by both aldehydes and ketones, but there is one condition. If in a compound CH3CO group is there, this group is known as methyl ketone. If in a compound methyl ketone group is there, then only it undergoes iodoform reaction, otherwise not. Methyl ketone group is the condition for this reaction. Methyl ketone group is the condition for this reaction. So let us suppose you have CH3CO, any compound with CH3CO group. This is, I will take butanol. When you react, iodoform में the reagent is I2 and NaOH, iodine and NaOH, again base, iodine and base. And in place of this, we can also write NaOI. It is same thing. NaOH and I2 will give you NaOI. It is same thing. So what happens in this reaction? The CH3 group, methyl ketone ka CH3 group, this group, it will convert into iodoform, CHI3. Don't write it at CH3I because here it is CH3 and 99% of the students write in this reaction CH3I. CH3I is methyl iodide. It will form CHI3, which is iodoform and yellow PPT. The remaining part gets oxidized to carboxylic acids. What is the remaining part? CH3, CH2, COO, Na. Because again a base is there, you will get a salt of acid. CH3 gets changed into iodoform, CHI3. The remaining part gets oxidized to salt of an acid, CH3, CH2, CONA. So the condition for iodoform test is methyl ketone group should be there. Only one aldehyde mainly can show this reaction because other aldehydes will not show this group. CH3, CHO, acetaldehyde. When you react it with iodine and NaOH, this CH3 group converts into iodoform, CHI3, and the remaining part, HCOONA, gets oxidized to acid. This part gets oxidized to acid. Now just go through once all the four reactions, then I will give you the questions to solve based on that reactions. So there were four under oxidation, KMnO4, Tollens, Fehling, iodoform. Tollens is ammonical solution of silver nitrate, AgNH3 twice. Fehling is aqueous copper sulfate and Rochley salt, give you copper 2 plus ions. Iodoform is iodine and base. Mika, what is the condition for tolerance test?
Ma'am, it's only for aldehydes.
It is only for aldehydes. Ketones does not give this test. Okay, now I will show you one question. All of you are done with the writing part?
Yes, ma'am.
Ma'am, just 1 second.
Yes.
Ma'am.
Now question is how they ask the question from, they will give one question and they cover everything. Now they give you the question, there is some organic compound A, listen carefully this question, having formula C8H8O. There is some compound with formula C8H8O forms orange red PPT with 2,4-DNP. On reaction with 2,4-DNP gives a orange or yellow PPT. Is the first thing they have given. Second thing they have given, and it gives yellow PPT when reacts with iodine and NaOH. When it reacts with I2 and NaOH, it gives you yellow PPT. And third thing they have given, it neither reduces tolerance nor failing. It does not react with tolerance. It does not react with failing. And it does not decolorizes bromine water. I will tell you what does bromine water reaction means. Next, on drastic oxidation, they have given, if we do the drastic oxidation of this, then it gives you compound B having molecular formula C7H6O2. What is the structure of A and B, and write the reactions involved. Now, how to solve these type of questions? It's very easy. It's not tough question. The first thing is you should know the structure of A. So in A, if the first thing you should know, if carbon and hydrogen number is almost same in number, almost same means C7H6, C8H8, C9H9, C9H8, like difference of 1 or 2, not more than that, is almost same in number, then always there is a benzene ring in the compound. It means benzene ring is there in a compound. So here you have C8H8O. From this molecular formula, what we can predict? In this compound, you have benzene ring. That is the first thing we can predict from the molecular formula of the compound. We don't know which functional group is there. Aldehyde hai, ketone hai, alcohol hai, ethers hai. We don't know which functional group. Now come to the second part. It reacts with 2,4-DNP to give you yellow PPT. Arjun, can you tell me 2,4-DNP is a distinguished test for which group?
Was it ketone?
No, but it 2,4-DNP is only for ketones, or it is for some other group also?
No, I think it's for both.
For both aldehydes and ketones. So we can say in general carbonyl group. It is a test for carbonyl group. So this reaction shows that your compound may be either aldehyde, because 2,4-DNP reacts always with aldehydes and ketones. So this compound may be either aldehyde or ketone, but we don't know whether it is aldehyde or ketone. That is from the 2,4-DNP. We know that there is a functional group, or wo functional group may be either aldehyde or ketone. Next is, Aditi, you tell me, on reaction with I2 and NaOH, it gives you yellow PPT. This is which reaction? And it tells you which group should be there.
It's the iodoform reaction, and it says ketone should be.
Yeah. Which group?
Ketone. The methyl ketone has to be.
Methyl ketone, CH3CO. So this reaction is iodoform reaction, which shows that this compound should contain CH3CO group, methyl ketone group. Now, it does not react with tolerance and failing. Shivani, tell me, if it does not react with tolerance and failing, it means it is a aldehyde or ketone?
It would be a ketone.
Yes, it will be a ketone because aldehydes reacts with tolerance and failing, but this compound does not react with tolerance failing, so it means it will be a ketone.
Mom, I had a doubt. I know for tolerance, ketones don't react. In Fleming, just specify that aromatic aldehydes and ketones don't react.
So from tolerance, we have ruled out the possibility of aldehydes.
Ketones.
So failing में all aldehydes are already ruled out. So it means it is a ketone.
Okay.
Agar if they will not mention tolerance, then there will be two possibilities. It may be ketone or it may be aliphatic. But aliphatic, again, the possibility is ruled out because we have already checked it has a benzene, and benzene is an aromatic compound.
Okay.
Now last is, what is the bromine water says? Bromine water shows the presence of double bond. So it does not react with bromine water. It means double bond is not there. Because if you remember, double bonded alkenes and alkynes reacts with bromine water, or you can say absence of unsaturation. That is a proper word. Reacts with bromine water and decolorizes it. So there is no reaction with bromine water. It means this compound is not unsaturated. So according to the things which we have find out, we will try to make the structure. There is a benzene ring. We found it is a ketone, and methyl ketone group should be there. So the compound I will make COCH3. I will write like this because I have predicted benzene. I have predicted this group will be there. When I attach this group to benzene, it becomes this one, acetophenone. Pradhanya, tell me, in this structure, how many carbon, hydrogen, and oxygens are there?
How many number of carbons?
How many carbons are there? We have to check whether it satisfies this formula or not.
There are 8.
Hydrogens? Is one hydrogen here also? 1, 2, 3, 4, 5.
Ma'am, and then there's 3 on top, so that should be 8.
And there is one oxygen. So this compound satisfies this formula also. So the compound which we have predicted and the compound which is A is acetophenone. Now we will see the oxidation part. Because it is a ketone, so it needs drastic conditions. That's why they have mentioned drastic oxidation. When we do this oxidation, bond breaks from here, from this side of CO. In this case, we will not use Popov's rule because if benzene is on one side, CO group always goes with the benzene. Because here, due to resonance, we will not break the bond from this side. You will get benzoic acid as a product. COH. It is C7H6O2. This formula is also satisfied. Benzoic acid. So this is how you have to predict the compound, and if they ask you to write the reaction, you have to write all the reactions. Reaction with 2,4-DNP, reaction with iodoform, and drastic oxidation. This is a 5-marker question. So this is your compound A. This is your compound B.
Can you repeat the last part again?
Oxidation.
Yeah.
See, when you do the drastic oxidation of acetophenone, because in Popov's rule we have done that CO goes with that part which has lesser number of carbon atom. But when you have benzene on one side, then bond always breaks from the other side of CO. The reason is benzene and CO always are in resonance. Resonance की वजह से there is a double bond here. So we can't break the bond from this side. The bond breaks from here. This CO gets converted into carboxylic acid upon oxidation, COOH. You will get one more acid from this side, HCOOH, but we can write only one because that is asked in the question.
Yes, ma'am.
I will give you one similar question. All of you are done with this? This is, I think, some example or in-text question in your book. Now, second, this I am giving you. There is a compound C5H10O. All of you have to tell me the answer for this.
Ma'am, can you go up for a second?
Yeah. This compound gives crystalline product with NaHSO3, sodium bisulfite. This compound does not react with tolerance and failing. Not with failing. This compound gives yellow PPT with I2 and NaOH. And upon drastic oxidation, it gives propanoic acid and ethanoic acid. Predict the structure of A. Predict the structure of A. Now try this question. First question is done for everyone.
No, ma'am. Ma'am, in the first question, Br2 indicates the absence of double bond, right?
Okay. Now, Shivani, you tell me, what is the meaning of it gives crystalline product with sodium bisulfite? Which group should be there?
It should be an ketone.
Only ketone or aldehyde? Maybe
Wait 1 second, no? No. It should be
aldehyde or ketone, because this reaction is given by both aldehydes and ketones. So it may be
Yeah,
aldehyde.
both, not just one, not just one.
So first statement shows that your compound may be aldehyde or ketone. Now, second one, Arjun, you tell me, does not react with tolerance and failing. So what does this statement says?
Ketone.
It's a ketone. Aldehyde possibility is ruled out. Now, which ketone that we have to predict? Aditi, yellow PPT with I2 and NaOH. Which group?
Ketone. It has to be a methyl ketone.
Methyl ketone. So this group should be there. So you have 5 carbons and we know that CO group should be with CH3. So it's easy to check the structure. CH3CO. How many carbons are left? 3 carbons. That we will on the other side. It is C5, H3, 4, 5, 6, 7, 10, O. If you do the oxidation of this compound under drastic conditions, what should be the product? We will cross check if this is correct or wrong. Bhumika?
Ma'am, it'll be
From where will you break the bond? Left side or right
to
side?
the right of the CO.
Hmm.
It'll be CH3 COH plus CH3 CH2 CH.
COH. Both this carbon also and this carbon also gets oxidized. So which is nothing but ethanoic acid and propanoic acid. So this
Propanoic
condition is also satisfied. This is your compound A. Pradhanya, what is the name of this compound?
Mom, CH3COH, right?
This one. CH3CO, CH2, CH2, CH3. What is the name?
Propane.
Tell me again.
Mom, propane, right?
5 carbons.
Okay. Pentanoic acid.
It's acid.
Ketone, right? It's ketone.
So pentane
On. Wow.
2 on. So your A compound is C5H10O is pentane 2 on. So like this you have to solve. See in this question, one question they have covered nucleophilic addition reaction, oxidation reaction, everything they have covered. Sometimes they cover reduction reaction also. Okay, this compound on reduction with zinc amalgam and HCl gives you that alkene. So in this type of question, they can cover many reactions. If you still have a doubt in any point, tell me, I will repeat. So this is all about the third type of reaction, which is oxidation. Now I will start the fourth reaction, which is aldol condensation. Again, that is a reaction which comes 100% in exams. In this chapter, there are few reactions which comes every year. That one among reductions, Wolf-Kishner-Clemenson, that one from nucleophilic addition, either arrange the products, either they will give you some reaction. One this type of question which covers all the oxidation reactions. And one aldol ka question. Now starting with the fourth reaction, aldol condensation. First we will do with the mechanism, then I will give you the shortcut of this reaction. Now what is
And this is
aldol?
the fourth point. I thought iodoform was the.
No, iodoform is the fourth point under oxidation.
Oh, okay, got it.
So oxidation is done. This is fourth chemical property. So aldol condensation, the condition for this is, first write down the conditions. Alpha hydrogen should be there in the compound. For aldol condensation, alpha hydrogen is one condition. What is alpha hydrogen? The hydrogen attached to the carbon next to the functional group. If you have CH3CHO, this is functional group. The carbon attached to functional group is alpha carbon. The second condition for aldol reaction is it always takes place in dilute alkali. Dilute alkali means they can give you dilute NaOH, they can give you dilute KOH, they can give you dilute barium hydroxide, calcium hydroxide, any dilute alkali always takes place in the presence of dilute. Wherever dilute alkali word is mentioned, it is aldol reaction. And the third thing here is the product of this reaction. Product is always beta hydroxyaldehyde. This is common. Beta hydroxyaldehyde is the product of this aldol reaction. This is important MCQ question. Beta hydroxy means OH group, aldehyde. Why this reaction is aldol? It has aldehydic group and alcoholic group. The product contains both alcohol and aldehydic group. These are the conditions for the aldol reaction. Alpha hydrogen, dilute alkali will be there, and beta hydroxyaldehyde is the product of aldol. You can say product instead of aldol. You can add product of aldol. In this reaction, always two molecules of aldehyde reacts, and you get the product CH3 CHOH CH2 CHO. This is beta. This is alpha carbon. This is beta carbon. Beta hydroxyaldehyde, which is nothing but aldol. Now I will tell you how this product is formed. Now all of you don't write it first, listen carefully, then you start writing. So in this case, what happens? This dilute alkali always abstract alpha hydrogen. This dilute alkali always abstract alpha hydrogen. Why it abstract alpha hydrogen only, not beta gamma hydrogen? The reason is alpha hydrogens are acidic in nature. It abstract alpha hydrogen. So when it abstract alpha hydrogen, what happens? The negative charge will come on CH2 because H plus goes, this bond is still here. So negative charge will come on CH2. You will get this product. This is nothing but carbon ion is formed. Now, why it abstract alpha hydrogen? Because alpha hydrogen is acidic. The reason is after removal of alpha hydrogen, the carbon ion which is formed here is resonance stabilized. Due to the resonance stabilization of the carbon ion formed, this alpha hydrogen is acidic in nature. I will dictate this reason. Alpha hydrogens are acidic. This is important reasoning question. Alpha hydrogen are acidic in nature because after removal of hydrogen, carbon ion formed is resonance stabilized. Because if product formed is more stable, the reactant is highly reactive. So this compound easily give H plus to form more stable carbon ion. That is the first step. Carbon ion is formed. Because in aldol reaction, we are using two molecules of aldehyde. Now this second molecule of aldehyde reacts with this carbon ion formed in the first case. I will repeat the second, because in this aldol reaction, if you see, we are using two molecules of aldehyde. So the second molecule of aldehyde reacts with the carbon ion formed in the first case. You know that this carbon is positive, oxygen is negative. So this carbon will react here because this is positive and CH2 is negatively charged carbon. So what you will get? Now you know that 5 bond with carbon is not possible. If this carbon is forming bond with CH2, there will be 5 bonds. Then what happens at the same time? This bond will shift on oxygen. So this CH2 minus gets attached on this carbon and oxygen bond will shift on oxygen atom. You will get CH2 CHO here.
Ma'am,
Yes.
can you repeat as to why it's called abstract alpha hydrogen? And is it a? I didn't actually. I don't know internet or. I just couldn't. I didn't understand if alpha hydrogen is in the product or it's part of the process.
I will explain this again. See, in this case, this is the first step of the, this is a mechanism of aldol reaction.
Yeah, yeah.
So the first step in the mechanism is when you use dilute alkali in the reaction, it abstracts the alpha hydrogen from the compound. Alpha hydrogen means the hydrogen which is attached to the carbon next to the functional group. This is alpha carbon, hydrogen attached to it is alpha hydrogen. Now the question comes, why it abstract only alpha hydrogen, not any other hydrogen from the compound? The reason is because alpha hydrogen acidic in nature. Why it is acidic? Because once alpha hydrogen is removed, the carbon ion which is formed here is resonance stabilized. There is a resonance in the carbon ion formed. So this compound has a strong tendency to release alpha hydrogen. That's why dilute alkali will take out alpha hydrogen and gives you the carbon ion which is resonance stabilized.
Okay. Okay, ma'am, got it.
In second step, the second molecule of aldehyde reacts with the carbon ion formed in the first case. So where this because carbonyl carbon is positively charged and here CH2 is negative, so these two will react and 5 bonds with carbon is not possible. So you can say that this bond will shift on oxygen atom. So this CH2 CHO gets attached on this carbon and O becomes negative. So if you do the acidification of this compound, O minus becomes converts into OH. This is nothing but the same product, beta hydroxy aldehyde. So you will get aldol here. Aldol means aldehydic and OH group on the same carbon, on the same compound. Now, in this case, if further they will, this is the aldol reaction, but sometimes they will ask you further, if you heat the aldol product, what happens? So if you heat it, the OH goes from beta carbon and hydrogen goes from alpha carbon. You will get alpha beta unsaturated aldehyde. Water is removed. So if you heat this compound, water is removed and you will get double bond. And this is known as alpha beta unsaturated aldehyde. Now all of you just go through once and write this equation. This is a mechanism of aldol. Shortcut I will tell you. First write on this part, then I will show you.
Ma'am, can you scroll down a bit? Yes, ma'am, thank you.
Is it done?
Yes, ma'am.
Okay, now I will tell you the shortcut of this reaction. Okay, if the reaction comes, how to do this. Now let us suppose they will give you this reaction. First I will write the same reaction with dilute alkali. You have to complete it. What is the product form? Now what you can do, there are two molecules of aldehyde. First ka carbonyl group you write in this way. CO. First you write CO in C double bond O karke. And the second molecule normal CH3CHO. First thing, you should mark alpha hydrogen or alpha carbon. You have to mark alpha carbon here. So what is the alpha carbon? This one. If you have beta gamma carbon also, that you write in branching. This alpha carbon, remove one hydrogen from alpha carbon. Remove this one hydrogen and add it with oxygen. And double bond gets shifted between carbonyl carbon and alpha carbon. So what you will get? CH3CH. This double bond O becomes OH. And this bond shifts between carbonyl carbon and alpha carbon. You will get this aldol product. So alpha hydrogen, only alpha, not the terminal one. It's the alpha hydrogen which goes with oxygen to form OH, and bond shifts between carbonyl carbon and alpha carbon. You get the aldol product. If heating is asked, then you remove water. Always write one molecule in the form of C double bond O and H. Another molecule normal, and mention first alpha carbon and then remove the hydrogen. Remove alpha hydrogen from second molecule. Second molecule. Shifts it with oxygen. And double bond shifts between carbonyl carbon and alpha carbon. Shifts between carbonyl carbon and alpha carbon. Make sure that you are forming the bond between carbonyl carbon and alpha. If any group is present to the right or left, you have to write in branching. Now I'm giving you one more example. Listen carefully. This one. Let us suppose you have CH3CH2CHO with dilute alkali. Now dilute word is there and alpha carbon is there, hydrogen is there. It means it is aldol reaction. So there will be two molecules. So first molecule I will write CH3C double bond O and H. And second molecule you can write as it is CH3CH2CHO. Now what is alpha carbon? This point listen carefully. This is alpha carbon. Mainly students what they will do, they remove hydrogen from terminal. CH2 is alpha carbon, so you have to remove hydrogen from here. So you just write alpha carbon at the terminal position. This CH3 group, instead of writing it this side, you can write in the branching. It will be easy. Mention alpha carbon. Whatever group is present on the left, you write it in branching. Then it is very easy to show the product. So in this case, what you can do, remove this alpha hydrogen, shift it with oxygen and shift bond between alpha carbon and carbonyl carbon. You will get CH3, CH2, CH. Here it becomes OH, CH, CH3, CHO. This is again beta hydroxy. This is alpha. This is beta hydroxyaldehyde.
Ma'am,
right-
CH2 will always be the alpha carbon.
The carbon which is next to the functional group. CHO ke adjacent carbon is alpha carbon.
Understood, ma'am.
This one. Now note down these two reactions. Then I will give you one more. And those who are done with these two, try this one. One I will give you butanol with dilute alkali. And there is one with acetone. Dilute alkali. Try these two. Bhumika, you tell me what should be the product for butanol? Bhumika?
Yes, ma'am. So the OH.
No, 1 minute. First molecule you wrote it like this,
Yeah,
or second को?
ma'am. I'm थोड़ा confused.
So alpha carbon ये है ना? So just write alpha carbon and CHO here. The remaining this group, write it in branching.
Okay.
It will be easy because this is alpha carbon. So this carbon you write at the terminal position. जो उसका बाकी group है, write it in branching.
So
This
for the first,
Hmm.
yeah, for the first molecule, won't the OH get added to the?
H here.
It'll come in place of the alpha hydrogen.
Which thing? OH.
No, it abstracts the alpha hydrogen.
Forget about the abstraction part. That is the mechanism. Shortcut से करना है. Shortcut में क्या है? यहाँ से you just remove alpha hydrogen from here and add it with oxygen. What it becomes? OH.
OH.
और ये जो one bond है, one bond shifts between CH
The
and this.
double bond comes between the CHO wala C.
So what you will get? This thing. बाकी part we have to just combine. It alpha carbon को write it at the corner, or the remaining part you write in branching. Then it will be easy to show the product. This is again beta, alpha, beta, beta hydroxyaldehyde. Always you will get beta hydroxyaldehyde. In case you will heat it, then OH and H is removed. Always alpha and beta carbon se removal takes place, and you will get alpha beta unsaturated aldehyde. Baki part as it is. Second molecule I gave you acetone with dilute alkali. Arjun, will you try this one? CSC2
Yes, ma'am.
molecule.
Just a minute.
Yeah. Yes.
Even if we don't write it like in the branched form, is it still fine?
It's still fine. Like your product should be like this. If you are writing in this way only, like Aditi, then answer should be same, right?
Yeah.
Then it is fine. Because
Okay.
why I have asked you to write in the branched form, because mainly what students do, they remove hydrogen from the terminal carbon.
But won't the longest chain be different? Like if we're trying to name it.
Just tell me what product you made for this one.
Ma'am, the CH3, CH3, CH2, CH,
CH2, CH2,
CH,
Hmm.
OH attached to that.
Hmm.
Then a CH2,
Hmm.
CH3 down, attached to it. And then CH and CH.
CH and CHO. That is wrong, because you have made bond with the beta hydrogen. You have shown the bond with this one. Alpha hydrogen is this one. The alpha carbon is next to the CHO.
Oh, okay. Yes.
I think you have removed the carbon from beta hydrogen.
Yes.
Ma'am,
Sajjan?
will it become OH?
Hmm.
The double bond, and then from alpha carbon, OH will go.
So tell me from the beginning, CH3.
CH3C and then OH and CH2.
Correct. Just tell me, my stylus is not, that's why I'm not writing. Continue. CH3, COH, and then CH2. उसके बाद Then
And then again CH3. This is the
COCH3.
branchy part.
That branching remains. See, why I have shown this CH3 in branching? Because I want this carbonyl group on the aldehydes. Mein carbonyl is already on the terminal position. But if you have ketones, carbonyl is not on the terminal position. So this group, whatever is there on the right side, we write it in the branching. So you can show the bond. I will write it. So it becomes CH3, COH, CH2, then COCH3 as it is. So this group in branching stays as it is. So it should be it should be CH3, C, CH3OH. I will write 1 minute. It becomes C, CH3, this as it is, OH. It becomes CH2, CO, CH3. Just check. Arjun, you have it in the same way?
I'll do it now. I didn't know
See.
that part.
Okay, I will tell one more thing. All of you, if you are confused here, just make sure that in first molecule, CO will be at the terminal position, carbonyl group at terminal position. And in second molecule, alpha carbon should be on the terminal position. Because we have to show the bond between these two. If there is any group like isme carbonyl ke baad you have this group, write it in branching. In the previous example, with alpha carbon, there were few groups attached. Write it in branching. And then you show the bond. Alpha hydrogen from the second molecule, it goes with O to form OH, and this bond shifts here. Is it clear or still confusing? Shivani, is it clear to you or some
Yes, ma'am.
confusion?
Yes, ma'am.
Aditi, what about you?
Yes, ma'am, I got it.
Because in this reaction, only two atoms are taking part. One is alpha carbon and another is the carbonyl carbon. So first molecule ka carbonyl carbon on the right corner and second molecule alpha carbon is on the left corner. Then you show the bonds. Whatever groups comes in between, you can show it in branching. This is all about the aldol reaction. I will show you there is one more reaction, cross aldol. It is same, just one difference is there.
Mom, do we heat this reaction like the previous one?
That depends. If they ask, you can heat it. If they have not asked, then you can leave it here also. So if
Mom,
they
if
ask,
you heat it, what will be the reaction?
same thing. This is alpha carbon, this is beta carbon. So water is removed. You will get alpha beta unsaturated ketone. Here it becomes double bond CH, CO, CH3. Alpha beta unsaturated ketone. I will tell you what is cross aldol. Cross aldol is same, but in aldol we are using only one type of aldehyde. You have either ethanol, propanol, butanol, acetone, one type. But cross aldol is with two different molecules of aldehyde or ketone. Let us suppose you have acetaldehyde and propanol reaction with dilute alkali. Now you have two different aldehyde molecules. You are reacting with dilute alkali. Now what is the product? So this is cross aldol when we have two different aldehyde molecules. So in this case, we are getting four products. Now what is the reason? The reason is because we are not taking single molecule of ethanol and single molecule of propanol. You have a solution of ethanol and solution of propanol, which you have a mixed with dilute alkali. So there are 4 different combination of products possible. What are the 4 different combination? Ethanol may react with propanol. Alpha hydrogen goes from propanol and you can show the product. This is A. Second is propanol reacts with ethanol. It's not same, it is different. It looks like reactants are same, products should also be same. No. Because in this case, we are removing alpha hydrogen from here. In second case, we are removing alpha hydrogen from ethanol. Third possibility, because when you are adding dilute alkali to the solution, ethanol molecule may react with ethanol only. 2 ethanol molecules may react. What is the fourth possibility? 2 propanol molecules may react. So there are 4 possibilities. Ethanol with propanol, propanol with ethanol, 2 ethanol or 2 propanol. Because it's not possible to take one molecule. When you have a solution and we are adding dilute alkali, so these 4 are the possible reactions which takes place. Now, all of you just complete this reaction, then I will ask you one by one the products. In first case, you remove alpha hydrogen from propanol. In second case, from ethanol. Third case, both are same. It's simple aldol. You can do it. Write in the same way which I have told. First molecule ka CO on the terminal position. Second molecule ka alpha carbon on the terminal. And then show the products. Yeah, first one. Pradhanya, you try the first one.
Ma'am, the first one is going to be CH3 and CH, and then a double bond O, plus CH2 and CH3 in a branch, and then CHO.
Should not be double bond here. Here it should be OH. Because double bond O becomes OH. Right?
Yes, ma'am.
Because here it is like this. So this hydrogen goes here and double bond comes here. So second one, who will try? Bhumika, you try the second one.
Yeah, so it'll be CH3, CH2, CHOH. And then CH3, CHO.
It's true, because this hydrogen goes there. Na?
Oh, okay.
This hydrogen goes there and this bond comes here. Next one, Shivani.
Actually, in the previous question, I have a doubt as to how we do for CH3 CHO. Because I know how to do the first one. How do we do the middle step for CH3 CHO? Can you? explain
This
again?
one you are saying?
No, second question. For CH3 CHO, how do we?
CH3, CH2, first molecule you will write like this.
Yeah, this is fine. I did that. The second, yeah, this part after this.
CH2, CH3, CHO, it's like this. What is alpha carbon here? This one only. So you remove,
Get a CH3 CHO.
so you can remove one hydrogen from here. It becomes CH2. So this hydrogen which you have removed, it goes from oxygen to form OH and this double bond shifts here. So we'll get CH3, CHOH, CH2, CHO.
Okay, 1 second.
Move one hydrogen from alpha carbon it goes with oxygen and shift double bond between carbonyl and alpha carbon.
Then why don't we add an H in the final answer? CH2, CHO. Why don't we add an H there?
Is then with double bond O converts into OH.
Oh, okay, got it. All right. Okay. Oh, ma'am, third question.
Mhm.
I have to do it. 1 second. It'll be the same thing, the CH3, CH. First one will be CH3 attached to CH and then double bond plus CH2, CHO and then a H attached
Attached where?
with the C and CH2. Oh, no, not yet.
Will come.
I was talking about the intermediate step. 1 second. Yes, I'm getting that only.
I think you are still confused. I will tell you one more thing. See, this is the two molecules which are reacting. Just I will give you one example. Okay, these two molecules are reacting with dilute alkali. Now, in first case, you have to write CO separately. CHO ko how we can write in the form? C double bond O, same thing.
CH, A double bond. I got that.
Now, second, may you mention what is alpha carbon? Is molecule mein what is alpha carbon?
Mom, I got CH to CHO and then I add an H in the middle step.
That is fine. First, tell me, Shivani, here, what is alpha carbon in the second molecule? CHO or CH3? Which one is alpha?
CH3.
CH3 is alpha,
Yeah.
right? So instead of CH3, we can write CH2
CH2
and
and
H.
yeah, ma'am. We did it. I did it. I thought you're asking me the entire process. I was still solving it because I had a doubt in the previous question. This I got.
Got it? This one.
Hmm.
Yeah. Arjun, last one.
Will it be CH3, CH2, and then
Yeah.
CH with OH on top,
Hmm.
and then CH2, CH2, and CHO?
Dekho, again, you made the same mistake. What is the alpha carbon in the second case? CH3 or CH2?
CH3.
No, alpha carbon is the carbon next to the functional group.
Oh wait, yeah, CH2.
CH2. So ये CH3 कहाँ आएगा? It should be in
CH. It
branching.
becomes CH3, CH, and then, yeah.
Now tell me the product.
CH3, CH2, and then CH with OH. Single bond CH2 with CH3 down, and then CHO.
Yes. Down or up, that is same thing, branching. So that should be the product for this. Because here you had alpha carbon is the next one. So CH3 is in branching. So here you have to write this C double bond O like this. So this alpha hydrogen goes with oxygen to form COH and the bond comes here. So this is how this is a cross aldol. All four are the products of that reaction. If in that reaction you are writing one product, you will not get the marks. These all four products you have to show. Now last reaction, Aditi.
Mom, isn't two of them the same?
Which one? Which
The
two?
first and the last is same, second and the third is same, right?
No. If you see first one, CH3, CHOH.
Okay, yeah. The
Last
second, okay, I understood. Sorry.
Aditi, the last one you tell me, benzaldehyde plus acetone. What should be the product here with dilute alkali? Benzaldehyde does not have alpha hydrogen. It has no alpha hydrogen. So that is because this is alpha carbon and all four bonds are like this. So there is no alpha hydrogen. It's where you have only one product possible. You have to remove a hydrogen from only this side.
So it'll be the benzene.
Hmm.
Then COH, CHOH, CH2, COCH3.
Yeah. Because this is alpha carbon. So this hydrogen goes with oxygen to form OH and then CH2CO CH3. So just practice the aldol reaction. It is not very hard. Only thing is you should know what are the alpha carbons. So the shortcut method only you have to practice. So remove the alpha hydrogen from the second molecule, attach it with carbonyl oxygen, and double bond shifts between carbonyl carbon and alpha carbon. And in this case, always you will get the product as beta hydroxyaldehyde. If in case you are not getting beta hydroxyaldehyde or ketone, your reaction is wrong. If you see in all the reactions, we are getting beta hydroxyaldehydes at the product. This is alpha carbon, this is beta. Alpha, beta. In all cases, OH group is on the beta carbon. Okay, now just 2 more minutes. We'll finish one more reaction. Then this aldehydes ketones parts will be done. After aldol, the last reaction here is fifth one, Canizaro's reaction. This is again a naming reaction. Canizaro's reaction. Next class we will do the questions based on these reactions, and naming reactions I will tell you how to learn everything from this chapter because there are a lot of reactions. Canizaro's reaction, the condition for this reaction is it is opposite to the aldol. There should be no alpha hydrogen. Alpha hydrogen should not be there for Canizaro's reaction. It is given only by aldehydes, not by ketones. Only aldehydes gives Canizaro's, not ketones. There should be no alpha hydrogen. It takes place in the presence of concentrated alkali. Aldol takes place with dilute alkali, Canizaro's is with concentrated alkali. And last, this is a disproportionation reaction. Disproportionation reaction. What do you mean by disproportionation reaction? Who will tell me? Bhumika, can you tell me what is disproportionation reaction?
I'm not sure.
Disproportionation reaction is that in which the same molecule undergoes oxidation as well as reduction. Disproportionation reaction, last year we have done in redox. Molecule undergo reduction and oxidation, same molecule. It will reduce as well as oxidize. Now in this case, let us suppose I am taking formaldehyde. There is no alpha carbon. If there is no alpha carbon, it means there is no alpha hydrogen. So in this case, this is aldehyde. One molecule of formaldehyde is reduced to alcohol because aldehydes upon reduction gives you alcohol. And another molecule of aldehydes gets oxidized to carboxylic acid. Again, we are using base here, so you will get the salt of an acid, HCONA or HCO minus. Yes?
Mom, I got logged off because of my internet. Mom, we finished this class. I was there till we finished the fourth example of cross aldol. What did we do after that?
After this, we have started this one, Canizaro, last reaction of aldehydes and ketones, which is Canizaro's reaction.
Okay.
These are the conditions for that. There should not be an alpha hydrogen. It is given only by aldehydes, not by ketones. It takes place in the presence of concentrated alkali. And it is a disproportionation reaction in which the same molecule undergoes reduction and oxidation.
Okay, ma'am. Thank you, ma'am.
If we are taking formaldehyde, one molecule of aldehyde is reduced to alcohol. Another molecule of aldehyde is reduced to carboxylic acids. If you are using NaOH here, you will get HCOONA. If you are using KOH here, HCOOK, salt of an acid is formed. Another example, if you have benzaldehyde, because benzaldehyde also doesn't have an alpha hydrogen. So in this case, one molecule of benzaldehyde will reduce to alcohol. Don't write, this is again a common mistake. Don't write benzene with OH, phenol, because there is a carbon here. It should be CH2OH, benzyl alcohol. And another molecule gets oxidized to acid, COONA. If you do the acidification, you will get COOH, but because of base, it is CONA. So Canizaros के लिए condition is very important. The compound should not have alpha hydrogen. In both these compounds, formaldehyde and benzaldehyde, there is no alpha hydrogen. They both show Canizaros reaction. And concentrated dilute is aldol is dilute, Canizaro is concentrated alkali. Disproportionation reaction, one molecule is reduced to alcohol, another is reduced to acid. So with this, the main reaction, there is one electrophilic substitution that we will do in next class, but mainly aldehydes ketones part is done for this chapter. In next class, we have to start carboxylic, but first we will practice the questions of this topic. All of you, please learn thoroughly all the reactions. Nucleophilic addition reactions, reduction, oxidation, aldol, Canizaros, these 5 reactions.
Done, ma'am.
Done? All of you are done with the writing part?
Yes, ma'am.
Okay. So prepare, those who have not written the test, write it today. I think Arjun, you are only writing it today. Aditya and Bhumika, you write after your exams. Okay, then we will wind up. Shall we wind up? Any doubts?
Ma'am, I have to ask
Yeah.
you something. It's not related to the chapter.
Okay, I will wait. Okay, then we'll wind up. Thank you.
Thank you.